Welcome to this Gastric Alimetry Report interpretation video. My name is Professor Greg O'Grady, and I'm the co-founder and CEO of Alimetry. In this video, I will take you through the steps required to interpret a Gastric Alimetry report. The Gastric Alimetry Report is made up of 6 sections: the summary, the spectral, the symptoms, the symptom association, and the gut-brain and technical sections. We recommend you follow this test interpretation framework to get the most out of your Gastric Alimetry report. The steps in this framework include looking at the test summary, then test quality to determine if you need to interpret your results with caution or not, and next is analysing the spectral and symptom data before looking at the symptom association data and the gut-brain data. Finally, you will be able to formulate a clinical summary using these findings based on your individual patient's context. The test summary page is the first page of your Gastric Alimetry report. This page contains a high-level overview of all key sections of the report. You'll find the spectrogram information and key spectral metrics as they compare to the validated normal reference intervals. The symptom analysis section provides total symptom burden data alongside symptom tags. The test protocol and quality gives you an overview of the test duration and the meal consumed, as well as the key quality metrics, which we'll cover next in this video. And in the bottom right, there is a summary of the patient's responses to the gut-brain wellbeing survey, which looks at their mental wellbeing symptoms leading up to the test. Down the bottom of this page is a section for you to complete your clinical summary once you've interpreted the report. And if you want, you can also access a file of the report interpretation guide in written form via the bottom of this section. We'll come back to this page at the end as part of forming your clinical summary. The next step in the test interpretation framework is to analyse the test quality. All of the relevant test quality data can be found on page 2 of the report, down the bottom of the page here. There are 4 measures of test quality that should be checked. Look at the test protocol box on the far left. A validated test protocol is a test that's over 4 hours in duration and where over 50% of the validated meal type has been consumed. The test is validated for a BMI of less than 35. If the patient's BMI is over 35, you will need to interpret the results with caution. Next, check how much artifact has been detected. If the artifact is above 50%, then you may need to interpret the results with caution. And finally, look at the impedance graph on the right and check that there was good impedance in most of the channels. If the majority of channels are poor, then you would need to interpret the results with caution. If any of these quality metrics happen to fall outside the validated range, then an orange box will appear around the section to alert you that the results should be interpreted with caution. Once you've checked that the test quality metrics are satisfactory, you can move on to analysing the spectral data. You will also find these on page 2 of the report. The high-resolution spectral plot depicts the frequency and amplitude of the gastric activity over the course of the test. Frequency is plotted on the y-axis and time on the x-axis. The amplitude is shown according to a scale from blue to yellow, with yellow indicating strongest signals. And underneath is a graph of the amplitude on its own, alongside the total symptom burden. The table beneath that gives objective information on the 4 different metrics of gastric function. The 4 metrics are shown for the pre-meal fasting period and then averaged over every hour post-meal and then summarised into the overall score. They are the principal gastric frequency, which is the intrinsic gastric frequency as shown by the yellow line after the meal, reported in cycles per minute. The normal range is between 2.65 and 3.35. The Gastric Alimetry Rhythm Index, which is a measure of the stability of the gastric activity, is shown by how stable that yellow line is after the meal, and that's plotted between 0 and 1. Higher values indicate greater stability and lower values spectral scatter. A value of about 0.25 is considered to be in the normal range. The BMI adjusted amplitude, which is the amplitude of the gastric signals corrected for the patient's BMI, reported in microvolts. The normal range is between 22 to 70. And lastly, the fed to fasted amplitude ratio, which is a measure of the increase in the power arising after a test meal. The normal range for this metric is above 1.08. Compare the 4 spectral metrics with their relevant reference intervals on the right-hand side. If any of these metrics are outside the reference range, this will be highlighted with an arrow to show whether the metric is above or below the normative range. Next, take a look at the amplitude curves. Things to look for here are whether there was a meal response, if the patient had a high fasted baseline, or if they had a delayed meal response. Transient abnormalities in the spectral metrics can also arise. Transient abnormalities are captured in the hourly metrics alone, with the overall test metrics being normal. As there are only reference intervals for the overall metrics, assessment of transient abnormalities should be performed on a case-by-case basis, looking at the hourly measures. For example, low amplitude or Gary before a meal would be expected because the stomach is quiet during fasting, whereas an hour of abnormal frequency or low Gary immediately after the meal may be indicative of a transient gastric dysfunction, even if it is later followed by normal activity, and particularly if it's associated with symptoms. An example of this is shown here. Moving on to the symptom analysis section, this can be found on page 3 of the report. Both discrete and continuous symptom events can be found on this page, and the symptoms are grouped into nausea and vomiting symptoms, pain symptoms, postprandial distress symptoms, and burning and reflux symptoms. Continuous symptoms are reported on a scale from 0 being none to 10 being the most severe imaginable. Assess the symptom severities and which, if any, subgroups of symptoms have the highest overall symptom severity. Next, look at the symptom curves. We look for whether there are any symptoms at baseline or if the symptoms change with a meal. And additionally, how do the symptoms change over time after the meal? Do they decline? Do they remain continuous? Or do they trend upwards at the end? Some symptom curves are associated with symptom tags to help with your interpretation. The tags used are meal-induced, which is when the symptom increases in the first hour post-meal relative to the baseline. Meal-alleviated, which is when the symptom decreases in the first hour post-meal relative to the baseline. And late onset, which is when the symptom increases 3 hours after meal completion. Continuous is when the symptom remains consistent throughout the test and is not meal-induced, meal-alleviated, or late onset. Finally, look at the discrete symptom events. These are grouped alongside the continuous symptoms in their respective subgroups. Note any relationship between these discrete symptom events and any abnormalities on the spectral plot. Look at how often these symptom events occurred and when in the test they occurred. The early satiation score is also displayed on the page. This is rated by the patient immediately after finishing the meal. 0 is none, and 10 is the most severe imaginable. The association page on page 4 showcases the symptom correlation plots, which show you how strongly each symptom is correlated with the gastric amplitude throughout the test. Correlations are not plotted if the symptom didn't change. A symptom correlation score of above 0.5 is considered significantly correlated with gastric amplitude. These symptom plots will also be tagged with a sensory motor tag to indicate that this has occurred. Next, the results of the gut-brain wellbeing survey are shown on page 5 under the gut-brain tab. Patients are asked to complete this survey before their test starts. A series of 10 questions are asked to gain an understanding of the patient's mental well-being in the 2 weeks prior to the test. The questions ask about the following areas listed here. These have been grouped into depressive, stress, and anxiety subgroups, and additionally, patients are invited to add additional context to their survey responses if they wish. If they have added anything, it will be displayed in the patient comments section down the bottom. Patients might also choose to decline the survey, in which case you'll just see a note saying that the patient declined to participate in the survey. The patient may or may not choose to give a reason for declining, and please note the wellbeing survey questions can act as a screening tool for patients who require further mental health evaluation, but they're not in themselves diagnostic of any mental health disorder, and are not intended to be a substitute for professional clinical evaluation. We've now covered all of the relevant information in the report, and it's time to pull everything together into a conclusion. First, summarize the key spectral information. Is the spectral data normal or abnormal? If there are any abnormalities, what are they? And noting whether they are over the whole test duration or just transient. Next, consider the overall symptom profile. Things to consider are what subgroup or subgroups do the symptoms mainly fit into, what's their severity, and if there are any symptom tags associated with these symptoms. Are there any notable symptom events? And additionally, are any of the symptoms strongly correlated with the gastric amplitude? It might also help to consider whether the patient's gut-brain wellness score shows that adverse mental health factors may be contributing to symptom presentations. The spectral and symptom profiles should allow you to consider which phenotype the patient falls into. Abnormalities in the spectral profile can indicate motility phenotypes such as dysrhythmia, high frequency, or weak or low amplitudes. If the spectral data is all within the normal reference intervals, it can indicate a sensory phenotype such as a gut-brain or sensory motor condition as per the patient's clinical profile. The full gastric alimentary phenotype map will be discussed in a separate video when we will go through the main groups of abnormalities that have been detected with the test. As with drawing any clinical conclusion, it's important to take into account your patient's clinical context and all the other relevant information. So that concludes the report interpretation process. If you have any questions about this, your Alimetry representatives are always available to support you.